Good afternoon. Today we will be discussing about the shallow foundation. Okay. So we already have seen some of the lectures from subsurface soil explorations, from where we get the idea how to do the boring for the soil and how can we get the sample, and we discuss some of the sampler techniques and also some of the testing methods. And additionally with that, we also studied how can we extract the soil parameters from the n value of SPD test, and how do we adjust the n value to n60, n60 to n160, and we develop some correlation with the soil properties. Okay, so once we know the soil properties, then our next steps is to know about the foundations. So in the foundations, and in this chapter especially, we'll be discussing about the shallow foundation. So before we move to the shallow foundation, first we want to know what is foundations, though you have some idea about the foundations, right? So normally the structures can be divided into two main parts. One is called superstructures, another one we call substructures,
Structure.
right?
Yes,
So
yes, sir.
substructures we call below the plinth level, and superstructures we call above the plinth level. So one is above, another is the below. Okay. So substructures is otherwise known as the foundation, but not always is the foundations. I will discuss also, and these form base for any structures, right? Normally the substructures, if you look into this figure, these are the substructures of these structures, right? So why not always substructures are the foundations? Because sometimes you might have 2 to 3 story building extension below the ground, so that time you may not consider this is as a foundation. But if it is only the foundation purpose member, that time we call it foundations. Okay, so generally 30%, how much? 30% of the construction cost is spent on the foundations. It's a handsome number, right? 30% of your total construction
Yes, sir.
cost is foundation work. And this soil on the sorry, the soil on which foundation rests is called foundation soil. Suppose this portion of the soil we call the foundation soil. Okay.
So when, like, if there's a basement or underground parking being made, is that also considered into the foundation price or in
Yes,
separate?
that will also consider underground parking, because in underground parking you will find the mat foundation. Okay.
Yes,
You'll
sir.
find the mat foundations. So the foundation is this, right? And this is the car parking area. Clear?
Yes, sir.
Okay. Okay, so why particularly we study the foundations? There might be some reasons or purposes. We need to know some purposes, like, or the reasons that why do you want to study the foundations. So some purposes, if I specify, that distribute the load coming on the structures, that the load coming to the structures, right? It needs to transfer, right? Suppose if you consider this the structure, sorry, the load is coming to the foundation, so this foundation needs to distribute the load. Or if I discuss in another way, suppose load is coming from the footing, sorry, from the column to the footing. Okay, so this footing is transferring to the load to the soil. So this is the simple mechanism. So we need to know this mechanism. To know the mechanism of transferring this load, we need to know the foundations, right? Foundation behaviors. So that's why, to distribute the load. To support the structures, definitely on top of it maybe we have structures. So to support these structures, we need the foundations. To give enough stability to the structures against various disturbing forces such as earthquake, wind and rain. So it's not always that just only the load you are having that you need to transfer to the ground, or stability you need to think of it, but you also need to consider earthquake, some special environmental conditions or some extreme environmental conditions like wind 1, earthquake 1, and rain. Sometimes it is heavy rain, so soil is having some problem due to this raining or water coagulations. And if it is earthquake, definitely you're very much aware of it. And wind also, nowadays you have seen, just recently we have like a wind storm like Amphan. Okay, so these case extreme conditions also we need to support our uh, structures, so we can also prepare our structures to make the stability for these conditions. To prepare a level surface for concreting and masonry workers, sometimes you will find for very small or light structures, we just consider some foundations just to leveling the surface and just to start the masonry work. Okay, like the bricks foundations you can see in the village, maybe it's not needed for the load taking capacity. Sometimes you just need a plain surface to start the brick work, right? And just little bit of foundationing also. So in case of bricks work you can see. Okay, so now the types of foundations. So in your regular life, you have seen several types of foundation. Maybe you are not aware of the uh, name, so you can look into it in specifically. So like we consider based on the depth two types. What are these? One is the shallow depth foundation, another is the deep foundation. So by word, it is easily understand what does it mean by shallow foundation. That means the depth is not much, right? So usually the footing we consider the shallow foundations, and the deep foundations. So deep foundations are pile foundations in usual cases. Okay.
Yes,
So
sir.
now type of shallow foundations if I go, so isolating footing, right? It might be single or column footing and combined footing. So you can see some of the examples of footings here. And in case of the type of deep foundations, we go for the pile foundations or pier foundations. Okay, so pile foundations that you usually see, and pier foundation is some kind of massive amount of uh, piling that you sometimes find for the heavy structures, right? In like for metro rail project in Bangladesh, you might see some of the pier foundations.
Yes, sir. So like Padma Bridge.
Okay, so now if I just give you a mind map of the foundation categories in a just in a more specific categories way, then you can see shallow foundations can be split into two way: isolated footing, another is the combined footing. And isolated footing like pet foundations, like only one column, one footing, something like this. And combined footing, you can do with the strip foundations or you can do with the ref foundations. Okay, so strip foundation, ref foundations are like strip foundation is suppose you have like unity strip like this, maybe you have two column here, right? And for mat foundations, you have the total area you covered with the foundations and you have maybe all the columns inside this mat. Okay, so then in case of deep foundations, we can go for the pile foundations and pier foundations. And especially uh, for the uh, pile foundations, you will find two kinds. One is the frictional pile and another is the bearing pile. So
Load bearing pile.
these two types we will discuss in details maybe while we'll be discussing about the pile. So if this is the pile and coming load here, right? And if these are the soil surface, so some frictional force or resistant force would be uh, on the surface of the pile, right? So you can
Yes,
see,
sir.
so this frictional resistance will allow to carry the load. And in case of the load bearing, maybe end of this there is a basement of soil, right? So in that base,
Yes,
what is
sir.
the direct resistance is getting from the soil in the end, that is called the load bearing pile. Okay,
Yes, sir.
So since this chapter we designed to study the shallow foundation, so we'll be specifically look into the shallow foundation categories in more details. So if I consider shallow foundations in two categories, one is the footings, another is the so one is the regular footing, another is the reft one or mats, right? So in case of footing, you will get the straight footing, and you'll get the straight footing and combined footing. So you can look into the book chapter about some pictures of about the pictures of this straight footing, straight footing and combined footing. So but I'm discussing in more details. I will upload the chapter 3 also, no problem. So in case of continuous strip wall footings, like you sometimes you find some sort of small structures or light structures, you have this kind of suppose this is the length of use length L. So you'll find all the columns are on this footing, right? All the columns, right? And suppose this width is very small, maybe suppose this width is 0.3 meter. 0.3 meter means 300 millimeter, right? And this might be suppose 30 meter. You understand? So I will look, compared to this 30 meter dimension, this 0.3 is very small. So this kind of footing we call the continuous strip footing. Maybe you can see some of the industrial shade or some of the shade where they just only need to keep some storage, need to keep some goods to store. So in that storage they consider for the strip footing.
So, sir, it's actually meant for lightweight structures like steel structures and all that, right?
It can be also for steel structures, no problem. But it depends on your soil conditions and your structure types. But sometimes you'll
Sir,
find
yeah.
they just cast one strip footing, and on this strip they put the all column. You know the meaning of
Sir,
strip, right? If it is the
yes,
total
sir. Yes, sir.
slab, suppose if it is a total slab, if you consider this one, this small portion, that time you consider this the strip, right? Like compared to the length, which is very small. So in case of isolated one, that is the individual footings, it can be, you can see these pictures, it can be like different kinds of, okay, the individual one, isolated one. So here you can see the types based on the padding conditions, right? This is simply pad footing. It is stepped one if you have some steps here, and this is a sloped one if you have the slope on this one. But here we are considering the shape only. It might be square, it might be circular, it might be rectangular if you consider the shape. Okay. And cantilever one, if you have the similar kinds of footing, but you have the cantilever portion on the footing. And in case of combined footing, you can see this might be rectangular and trapezoidal. So when do you need the combined footing? Do you have any idea from the RCC? Okay, so suppose these are the columns you have. Okay, that the reason you said, if the two columns are very nearly, that can be also reason. But normally, whenever you have the column management like this and you have the property line of this, right? This is the PL property line, if I consider, right? So don't, this is not the pint level, this is the property line, suppose. So if you consider this is the property line, and you find that the footing area for this one is like this, so that time it is difficult for you to construct this footing because it is not under your property line. So that time what you are doing, you try to combine either these two or with this one, and you finally try to make the stabilizations or what is called design requirement for this. So maybe you can consider the footing of yours is like this, maybe one column here, another column here. And what does it mean? So you are inside the property line. Okay. This kind of shape can be rectangular and trapezoidal also. Okay. And in case of raft, I already discussed. In raft one would be like, or the mat one would be like total area of the structures, and you just consider all the foundations here this way. Okay, so all the columns inside the foundations will be here. Right. Now when you'll say, okay, you will go with shallow foundation, this is very important. Like many a times you'll find many of the maybe landowner or some people will ask you, okay engineer, so tell us that when do you need the pile or do you need the shallow foundation or something like that, that I'm going to build this much or this story, right? So there is no specific answer for the based on the story. Even it might be fifth story residential building, okay, you may need pile, right? It depends what are the conditions we need to satisfy. First of all, you can see there are two main conditions we need to satisfy, then we can deal with it, right? So one is that uh, they have to be safe against overall shear failure in the soil that supports them. Okay, normally they have to save who the structure, right? And foundations conditions need to be safe that it does not occurs shear failure. You understand? So first of all, the footing, whatever the footing you are considering, should be sufficient enough to take the load coming from the superstructures. Okay, once this condition satisfied, okay, you can say, okay, shallow foundation can be give, but you need to also check what, that they cannot undergo excessive settlement or displacement. You first consider that, okay, the structures requirement on in case of the uh, loading is okay. Suppose load is coming here and you are having the footing, so no problem, it is giving you the safety margin in terms of the load capacity, but it is showing the higher amount of settlement. So that time will you select it? Hmm?
No, sir. No,
No.
sir.
No,
So
sir.
first of all, you need to think of about the capacity, right? And then you need to think of the settlement. If these two conditions are okay for the footing that you designed or the footing you have considered for your structures, that time okay, you can go for it. But if you find these are not supporting your requirement, so that time you have to go for the deep foundations. Is that understandable?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so now at least you understand there is no specific answer that if it is 5-story building there will be pile or footing, right?
Yes, sir.
This answer
Yes,
Depends on
sir.
depends on
soil.
the soil capacity and the
Sir,
foundation.
depends on soil, sir. Yes, sir.
Yeah, depends on soil capacity and the type of structures you have and the
Yes, sir.
amount of
Yes, sir.
load coming from the structures. Okay, so ultimate bearing capacity, what is ultimate bearing capacity, any idea?
Sir, maximum bearing capacity. Maximum bearing capacity.
Okay, so maximum load can be taken by the particular structures.
Even by
So
the soil.
if you consider about the soil, so it should be the soil capacity. So maximum load can be taken by the soil before fail. That should be the bearing capacity for the soil. So if you go with theoretical point of view, the load per unit area. So load per unit area means what? Stress, right?
Yes, sir.
Load per unit area, force over
Yes, sir.
area
Correct.
is stress. Okay, so the load per unit area of the
Force over area.
foundation
Yes.
at which shear failure in soil occurs. So normally if you find the ultimately bearing capacity of soil, after that, just after that, the soil will fail in shear. Is that okay? Or by reaching which point the soil will show the shear failure? That is your ultimate bearing capacity of soil. And the ultimate pressure per unit area of the foundation that can be supported by the soil in excess of pressure caused by the surrounding soil at the foundation level. Okay, so I'm repeating again though. the ultimate pressure per unit area, right? That is again the stress of the foundation that can be supported by the soil, okay, in excess of pressure caused by the surrounding soil at the foundations level. So foundations, up to which conditions these foundations can carry the load is coming, the load might be from the structures, might be from the surrounding soils, up to which level the soil can take the load, that limit we consider the ultimate bearing capacity. Okay, so soil can fail, right? Whenever you put extra load and you continuously increasing the load of the structures or load of the members or coming load to the soil, so that time soil shows the failure, right? So there are three kinds of natural soil failures we can see. These are shear failures. All are shear failures because we have seen soil shear failure is considered for the ultimate bearing stress or ultimate bearing capacity. So bearing capacity failure occurs when the stresses or the shear stresses in a soil exceed its shear strength, right? So if soil has a shear strength capacity of maybe 10 megapascal, and the stress you give from the building or the structures, it is maybe more than 10 megapascal, so that time the soil will fail. So that kind of failure will consider the shear failure. So how we consider or how do we define this failure in different way? This failure can be occur in different way, like this shear failure can be considered in general shear failure, it can be local shear failure, it can be punching shear failure, three way. So what is this general shear failure? So general shear failure is the picture, this one. If you want to look, if you can see into this picture, have a look. This is the B width of this foundations, then it is coming the load right on these foundations. So these foundations will show this kind of behavior after general failure. So what is this? We can see the failure surface will be developed like this. The failure surface or the shear failure surface of this foundation will be like this, right? Similar way this one also. And you will find some heap here, right? A regular heaping here while it settle, while it goes down. Okay. Okay,
Yes, sir.
so now if you look into the load versus settlement curve in this portion, load versus settlement curve, you can see while it is increasing the load, settlement rate in the initial stage is very small, right? And gradually it is increasing with the amount of load. But once it reaches to the ultimate state of it, once it reaches its ultimate state, that time it fails suddenly. Can you see? It's a sudden failure. So that's why I
Yes, sir.
quoted this term note as a note, that is the sudden failure in general shear failures, right? Is that clear?
Yes, sir.
Suppose this is
Yes,
your
Yes, sir.
settlement, this is your settlement range. Suppose in this point settlement is here and load per unit area, that is the stress of soil, is here, right? So gradually whenever you come to this point, while you do the testing, you'll find the ultimate QU or bearing capacity of the soil is this portion, right? And for this particular soil, maybe that is the ultimate settlement or maximum allowable settlement you can consider. Okay, so now we look for the local shear failure. So local shear failure generally occurs for the medium compacted type soil. It might be sand, it might be clay type, that we already discussed two types of soil conditioning in the last few lectures actually, that granular type and the cohesive type. So for local shear failure, this phenomena will happen for the medium compacted one. So how does it look when it fails? You can see the shear failure surface is extended up to here, right? Here you can see, and the heaping, you can see there are some partial heaping, right? It's not like the general shear failure heaping. And this is the foundation width, right? This is the foundation width. So the shear failure is exiting the, or it is going outward from the foundation width. That's why it's gradually extended towards the foundation. So from the foundation it's gradually extending, right? If you apply load here, do you understand this part?
Yes, sir.
Yes, sir.
Okay. So now you can
Yes,
see
sir.
into the load versus settlement curve. Here this is you can see this is having like gradual increment. When the load increase, settlement increase, load increase, settlement increase, and after this point you have a one sort of QU and one settlement, right? So what the researchers found that at this QU1, the soil, they are not considering as a final failure, they're considering as a initial failure, and which one is uh, considered as a failure load, or the what is called local shear failure. But the load taking capacity is still increasing. You see, it is increasing. If you increase the load, settlement is increasing. So still it is taking the load, but the line is like the rate is reduced compared to the settlement, but still it is taking the load, and that is the final what is called QU, where it fails completely, and after that soil goes like abnormal settlement. So in the research, researchers, they prescribe that we need to consider the QU1 for the initial uh, failure, and that would be the design consideration load for the local shear failure. And one another phenomena you will find here, after reaching or exiting this state, you will feel a jerking on the foundation. Foundation will have a jerking. You understand? Suddenly it moves to the next level, so that time it has the jerking settlement due to the settlement. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
And come to this portion. Here you can see the failure surface for this punching shear failure is not wider. It is just, if you consider the soil width B, so it is inside the soil width, right? The failure surface. And this failure of like the punching shear failure mostly occurs for the loose sand, right? For loose sand. So in that case, you can see the settlement. It is showing this one. Okay, so gradually. So this is actually all about the three types of bearing capacity failure in soil. So you can look more details from book to study in more